Chapter 4 is injections. So in Chapter 3, we did medications administered orally. So if we cannot administer medications orally, there's a couple other ways we can do it. And one of them is going to be through injections, which is going to be this chapter. And then we'll also do them intravenously, which is in the next chapter. So two of the common forms of injections are going to be intramuscular, which we can abbreviate that with IM, and that's going to be when it's given into the muscle. So intra being a prefix, which means within. And then we also have subcutaneous, which we can abbreviate sub-C, which is given just beneath the skin. And both of these injections are going to be using a syringe to administer the medication, with just the mild difference of the subcutaneous syringe having a shorter needle because it doesn't have to go very deep underneath the skin, and the intramuscular syringe is going to be somewhat longer so it reaches the muscle tissue. So the two types of syringes shown below here, the first one we have the intramuscular and the subcutaneous syringe, so that's this one right here. The needle for it can screw off and can be replaced with a shorter needle for a subcutaneous medication, which you can see right about here, the two different needle lengths. So this second syringe here is going to be for administering insulin, and we'll come back to that one in 1 second. So taking a note of the different scales on the syringe is kind of hard to read here. On the first syringe, we have 2 scales, and the most commonly used one is going to be milliliters or cubic centimeters. So remember, 1 cubic centimeter is equal to 1 milliliter, so they're exactly the same. And occasionally the minims scale will be used. And on the second syringe, we have the markings from 0 to 100, and that represents the USP units, or the United States Pharmacopoeia units, and those are not milliliters. And certain drugs like insulin, hormones, or antibiotics are going to be measured using that second syringe. And the advantage for them using this second syringe for something like insulin is that the patients don't have any calculations that they have to do. And the units can be abbreviated for the USP. They're abbreviated with just a capital U for the USP units. So medications that are given through injection are going to be manufactured in 2 different forms. The first one being prepared strength liquids. This is going to be a vial containing the medication that's already in liquid form. And the second one, the second form, is going to be a powdered medication. It's going to be obviously a powder, and it needs to be reconstituted, which means mixed with something like sterile distilled water before being administered. So starting with the prepared strength liquids, like we just mentioned, these come in vials for a single or multiple doses, or they can also come in a pre-filled disposable syringe. And as usual, on the label, it'll say the strength per dosage of the prepared solution. And what we have to do is we're going to have to find the needed information on the label and calculate the correct dosage to give. And just like what we were doing before with the oral medication, we're going to round this to the nearest tenth. Okay, so let's do a couple examples here. A physician orders 0.75 grams Cantrex IM. So once again, IM means intramuscular, it's into the muscle. And the label is going to read Cantrex 1 gram for every 3 milliliters. And we want to know how many milliliters should be given. Okay, so pretty similar to what we've already been doing. We're going to set up a proportion. And one side of the proportion, one ratio, is going to be the order itself. And the other side of the proportion, the other ratio, will be the on-hand drug. So here's the ratio from the order itself. We want 0.75 grams, and we're looking for milliliters. So 0.75 grams over X milliliters, and that's going to equal the ratio for the on-hand drug. So we have 0.75 grams over X milliliters equals 1 gram over 3 milliliters. So we have our proportion, and before we calculate, we should double check to make sure the units are the same, which they are. They're both grams per milliliter. So we can go ahead and just cross multiply and solve this for X. So cross multiplying here, we get 1 times X equals 3 times 0.75. And that's going to give us X equals 2.25. And rounding this to the nearest tenth, we get X is 2.3 milliliters. Okay, so pretty simple, pretty similar to what we've been doing. So let's do another one here. So we have an order of Toradol 1/4 grain IM stat, so intramuscular immediately. And on hand, we have 30 milligrams per milliliter. We want to know how many milliliters should be given. So let's set up the initial proportion here. So we're going to have the ratio from the order and the ratio from the on-hand drug. So I just changed, instead of 1/4 grains, I have 0.25 grain. So I have 0.25 grain over X milliliters, which is what we're looking for, equals 30 milligrams for every 1 milliliter. So notice here that the units are different in the numerators. So I'm going to change grains, the 0.25 grains, into milligrams, and then replace it in the equation, and then solve the proportion after that. So when we convert the 0.25 grains into milligrams, we have the conversion factor here. And I set it up using dimensional analysis. You can set up a proportion if you'd like. So 0.25 grains times 60 milligrams divided by 1 grain. And then once again, we notice that the grains cancel. We're left with milligrams. 0.25 times 60, we get 15. So we're going to replace the 0.25 grains with 15 milligrams, and we're going to set this proportion up the same way it was. Now it becomes 15 milligrams over X milliliters equals 30 milligrams over 1 milliliter. So we solve this for X, the units are correct, solve this for X, and we're going to end up getting 0.5 milliliters. Okay, so I just didn't show the work for solving the proportion for that one. So let's do another example here. So the physician orders heparin 8000 U sub C, so sub C, subcutaneous, under the skin, and the units here of U, that's the units that were introduced on the first page of this chapter. Those are going to be the USP units. And the heparin label that we have says 5000 U per cubic centimeter per cc, and we want to know how many cubic centimeters should be given. Okay, so let's set up this proportion for the order and the on-hand drug. So from the order ratio, we have 8000 U divided by X cubic centimeters, because that's what we're looking for. We're looking for X here. And that's going to equal the on-hand ratio of 5000 U over 1 cubic centimeter. So whenever, as usual, whenever it's not written, when there's no number written in the order or on the on-hand drug, if it just says per cc, that's per 1 cc. Okay, so once we have this set up, we double check, we look at the units. The units are the same. We have U divided by cc on both sides. So we can just go ahead and solve for X here, cross multiply. And I'll skip the steps for cross multiplying once again. We end up getting X is 1.6 cubic centimeters. So now for the powdered medications. So the reason that we need some medications in powdered form originally is that some drugs are going to be unstable in liquid form, which means they have a short shelf life, which means that the strength would weaken over time if they were in liquid form. So these drugs need to be prepared in a powdered or a crystalline form first, and before they're given to the patient, they have to be reconstituted, and that's going to mean they have to mix the dry medication, the powdered form of the medication, with a diluent. to prepare it to be administered to the patient. So the most common diluents are going to be sterile distilled water, normal saline, and bacteriostatic water. And the directions on the drug label will essentially always tell you the amount of diluent to use for mixing with the dry powder. And typically hospitals would have pharmacies that are going to prepare these in advance for the nurses, but we should definitely be comfortable doing this by hand ourselves. So something else that's going to be on the drug label is going to be the strength per dosage of the reconstituted solution. And this is needed to calculate the correct dosage that we give to the patient. And what's nice about doing these is we're going to be doing these the exact way that we've been doing these before by setting up a proportion. So let's do a couple examples here. So the order we have is DAC 500 milligrams intramuscular every 8 hours. So remember the Q8H means every 8 hours. And the label on the drug reads DAC equivalent to 1 gram. We need to add 3.2 milliliters of sterile distilled water for the injection. So that's the instructions for reconstituting it. And we know that it tells us that each milliliter contains 250 milligrams. So there's the strength per dosage, and we want to know how many milliliters should be given. Okay, so I just went ahead and labeled all of the information here. So it looks like there's a lot of information, so it looks kind of confusing. All we need in order to set up our proportion is going to be the order and the strength per dosage of the reconstituted solution. So once we know that that's all we need to set up our proportion, it's going to be exactly the same as how we were doing it before. And one other little note to keep in mind here, which I mentioned at the bottom of the page. Sometimes when we mix these together, we're going to have leftover medication. Some medications are going to be allowed to be saved for a certain amount of time before being thrown out, while other medications have to be discarded right away or immediately. Okay, so let's set up this proportion. So let's take a look at the order. The order is 500 milligrams, and we're looking for milliliters, so 500 milligrams over X milliliters. And let's take a look at the strength per dosage. So that was the order. And strength per dosage, it says each milliliter contains 250 milligrams. So setting this up, it's going to be 250 milligrams divided by 1 milliliter. And that came from the on-hand drug, which was the strength per dosage. So notice that those other numbers, the 1 gram and the 3.2 milliliters for reconstituting the solution, we didn't actually need those for the calculation with this proportion. So looking for X here, we take a look at the units. The units are both milligrams per milliliters. We can go ahead and cross multiply. And when we cross multiply, we're going to end up with getting 2 milliliters. Okay, so not that hard once you kind of weed through the information given. Yeah, let's do one more example. So we have an order of prostaflin, and it is 2 grains intramuscular twice per day. So remember, the BID means twice per day. The label on the drug, on the on-hand drug, reads it's equivalent to 500 milligrams. So that's the dry weight, and that's the powder weight. And then we need to add 2.7 milliliters of normal saline, and that's going to be reconstituting it. And we add that for the injection to yield 250 milligrams per 1.5 milliliters. And that's the strength per dosage. And we want to know how many milliliters should be given. So all we need here is, once again, the order. So here is the order. And we need the on-hand ratio for the strength per dosage. And now we can set up our proportion. So we have from the order 2 grains over X milliliters, which is what we're looking for. And that's going to equal 250 milligrams for every 1.5 milliliters, which is the on-hand drug, the on-hand strength per dosage. So we recognize that we have different units in the numerator. We have grains and milligrams. So let's convert 2 grains to milligrams. So converting that into milligrams, we're going to multiply by the conversion, which is 60 milligrams divided by 1 grain. The grains cancel, we get 2 times 60, which is 120 milligrams. So we're going to replace this 120 milligrams into the 2 grains, and we're going to, and from the original proportion, and we're going to set up a new proportion. And we get 120 milligrams over X milliliters equals 250 milligrams over 1.5 milliliters, and we cross multiply, solve this for X, and we get about 0.7 milliliters. Okay, so I just wrote out the cross multiplying for this last one here, and just notice that we rounded to the nearest tenth and got 0.7 from 0.72. Okay, so that is it for this chapter.